Now let's discuss about even numbers and odd numbers. And suppose you have numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11, then 22, then 33, 36, 37, 68, 92, 93, and 100. Suppose you have all these numbers, and if you are asked that out of these numbers, which numbers are even numbers and which numbers are odd numbers. So even numbers are all those numbers which are completely divisible by 2. That is, 2 is their proper or exact divisor. It means that if you divide that number by 2, and if the remainder is 0, that means that that number is completely divisible by 2, and therefore 2 is the proper or exact divisor, and such numbers are called even numbers. So in this list of numbers, you have 2 is completely divisible by 2, you have 4, you have 6, you have 8, you have 10, 22, 36, 68, 92, and 100. These all numbers are completely divisible by 2, that is, 2 is their proper divisor, and therefore these numbers are even numbers. So the condition for even numbers, the definition of even numbers is that these numbers are completely let's not say completely, they are divisible by 2. That is, 2 is their proper or exact divisor. Rest all the numbers which are not divisible by 2, that is, 2 is not the exact or proper divisor, rest all numbers would be odd numbers, right? So in this example, in this list of numbers, 1 is not divisible by 2, 3 is not divisible by 2, 5 is not divisible by 2, 7 is not divisible by 2. Similarly for 9, for 11, for 33, for 37, and 93. These numbers are not divisible by 2. That is, 2 is not their proper or exact divisor, and therefore these numbers are odd numbers. So odd numbers not divisible by 2. Okay. Keep in mind that the number 0 is neither an even number nor an odd number. Okay, so keep this number out of even numbers and odd numbers. Now suppose you are given an example, you are asked in a question that you have this number 32100798321 and 6, suppose. So you are asked whether this number is an even number or an odd number. So by the definition we saw that even numbers are those numbers which are divisible by 2. So if you would go by definition, then you would go on, you will start dividing this number by 2, and it would take a lot of time, right? It would take a lot of steps to divide this number and to check whether this number is an even number or an odd number. So is there any trick? Yes, there is a trick. And the trick is that any number's unit place, straight jump to the unit place of that number. So in this number, you have 6 at the unit place. Okay, this is the unit place of this number. And if the unit place of any number, if the unit place of any number contains the digits like 0, 2, 4, 6 or 8, if any one of these digits is present at the unit place of any number, then that number would be an even number, because that number would be divisible by 2. In this case, you have 6 at the units place, and therefore this number is an even number. This number is an even number. Suppose you are having, at the unit place you are having 1. Right now I have deleted 6. Now I have decreased 1 digit, and now you have this number. And now you are asked whether this number is an even number or an odd number. So in this case, you could see that this is the unit place of this number. And at the unit place, you have 1. 1 does not belong to this list of numbers, right? It has 1. Therefore, this number is not divisible by 2, and therefore this number is an odd number. So to check whether any number is an even number or an odd number, straight jump to the units place. Check whether at the unit place you have digits like either 0, 2, 4, 6 or 8. If yes, then that number is an even number. If no, then that number would be an odd number. Now let's discuss about prime numbers. So what are prime numbers? Well, any number which is greater than 1, that number should be greater than 1, and which has only and only 2 factors, or say it has only and only 2 divisors. So only and only 2 factors, or only and only 2 divisors, and one divisor or factor would be the number 1, and the next divisor of factor would be that number itself, that particular number itself. If any number greater than 1 satisfies this condition of having only 2 factors or having only 2 divisors, where one divisor is the number 1 and the next divisor or factor is that number itself, then that number would be the prime number. Example, take 2. Is 2 a prime number? Of course 2 is a prime number. How? You can write 2 as 1 multiplied by 2, that is 1 times 2, and this would be 2, right? Where 1 is one factor and 2 is another factor. There are no other factors other than 1 and 2 for 2, right? So 2 has only 2 factors. First factor would be 1 and the next factor would be 2. There are no other factors for the number 2. Therefore 2 is a prime number. Let's take another number, that would be 3. Is 3 a prime number? Yes, of course, 3 is also a prime number. How? So you can write 3 as 1 multiplied by 3, that is 3. Okay, therefore 1 is a factor of 3, or the 1 is a divisor of 3. We have seen in the previous video, and if you haven't watched those videos, then I request you to please go through those videos and you get to know that what are factors and what is a multiple. So 1 is a factor of 3 and 3 is a factor of 3, and there are no other factors apart from 1 and 3 for this number 3. Okay, so there are only two factors, that is 1 and 3, and no other factor. What about 4? Is 4 a prime number? No, 4 is not a prime number. How? Because you can write 4 as 1 multiplied by 4, right? This is one way of checking, but you can also write 4 as 2 multiplied by 2, right? This would also be 4. So you have three factors now. First factor is 1, next factor is 4, and another factor is 2. So you have three factors for 4. And remember, we know that 4 is an even number, and an even number is always divisible by 2, right? So we got from that point we could come here, we could calculate that 2 multiplied by 2 would be equal to 4. So there are three factors. What about 5? Is 5 a prime a prime number? Yes, of course, because 1 multiplied by 5 is equal to 5. 1 is a factor, 5 is a factor, and there are no other factors apart from these two factors. That is 1 and 5 are the only two factors for 5. So any such numbers which are greater than 1, this is an important condition. And always remember, you would say that, hey, I can write 1 as 1 multiplied by 1. Then what is the problem? It's also satisfying the condition that the first factor would be 1 and the next factor would be the number that itself. But no, 1 is not a prime number. We always take 1 as a unit. We always take 1 as a unit. And the condition for a prime number is that that particular number should always be greater than 1, right? This is the first condition. Therefore, 1 is not a prime number. 1 is not a prime number. And the next condition is this one that we discussed here, that it has only two factors or divisors, and the first one would be the number 1 and the next one would be that number itself. Okay, so this is all about prime numbers. What would be the next prime number after 5? Next prime number after 5 would be 7. Okay, and this would again be 1 multiplied by 7 would give 7, and there are only two factors, that is 1 and 7, and no other factors possible apart from these two factors for 7. So the recognition of prime numbers goes long back in antiquity, that is in ancient history. Long back in ancient history it was recognized, and it was being studied by the Greek mathematician, Euclid, and he is also known as the father of geometry, right? He is the father of geometry, and Euclid recognized prime numbers, and he gave in his theorem he proved that there are infinite number of prime numbers. That is, you cannot say that this is the limit of prime numbers, that beyond that we would not get prime numbers. He proved by his theorems that there are infinite number of prime numbers. Okay, and many mathematicians try to give some formulas, that they try to give some formulas to to tell that, okay, using this formula or using that particular formula, you could derive any prime number. But they all were wrong, they all have been flawed. So there is no certain formula or there is no certain method to calculate any number of prime numbers. Okay, so the formulas that were given by the mathematicians could not stand, could not pass a test, and they all have been flawed. And the next thing is, with computers that we use in our technology, with computers we have derived prime numbers having millions of digits in them. And so the point is that the study of these prime numbers goes long back into history. Euclid studied them, recognized them, and proved that, and he proved through his theorems that there are infinite number of prime numbers. Many mathematicians tried to prove that we can calculate any prime number using some formula, but they all have been flawed. And using computer, we have generated, or we have found that numbers which are numbers that are prime number and have millions of digits in them. And to understand composite numbers, let me just remind it again that what are prime numbers in a very short way. That for prime number, the condition is that first of all, that number should be greater than 1. That number should be greater than 1. And the next condition is that that number should have only two factors. That is, that number should have only two divisors. And the first factor would be 1, the number 1. Okay, the first or the one factor would be the number 1, and the next factor would be that number itself. Okay, that number itself. So like 2 or 3. So 1 multiplied by 2, and here 1 multiplied by 3. 2 and 3 both have only two factors, that is 1 and 2 for 2, and 1 and 3 for 3. There are no other factors other than 1 and 2 for 2 and 1 and 3 for 3. So the condition is that number should be greater than 1, and that number should have only two factors. That is, the first factor would be the number 1, and the next factor would be that number itself. Apart from that, there are no other factors. So such numbers are called prime numbers. Now, apart from these numbers, that is 1 and prime numbers, whatever number comes in your mind, all are composite numbers. They all are composite numbers except one. We discussed that 1 is always called as unit, and the condition for any composite number or a prime number is that they should always be greater than 1. Okay, so 1 is not a prime number and 1 is not a composite number. It always taken as a unit value. And apart from 1 and prime numbers, whatever number comes into your mind, they all are composite numbers. And the reason why? The reason is that the composite numbers will have more than two factors or divisors. They will have more than two factors or divisors. Let me explain you with an example. Take 8. Okay, number 8. What are the factors of 8? So the factors of 8 would be, you can write 8 as 1 multiplied by 8. Okay, then you can write it as 2 multiplied by 4. Now you would notice that the number 8 has 4 factors. What are the factors? First one is 1. The next one is 8. The next one is 2. And the next one is 4. So this 8 has 4 factors. It has 4 factors. And here we saw that for a prime number, the number should only have two factors, that is 1 and that number itself. Other than that, there are no factors. But in the case of composite numbers, you could see that, as we saw in the example of 8, it has 4 factors. Take another example, take number 4. So you can write 4 as 1 multiplied by 4, and you can write 4 as 2 multiplied by 2. So there are again 4 factors. There are 3 factors this time. One is 1, then is 4, and the next one is 2. So it has 3 factors. You can take another number. Take 6. So this 1 multiplied by 6, and the other way would be 6, 2 multiplied by 3. So 1 is a factor, 6 is a factor, and 2 is a factor, and 3 is a factor for 6. So it has total number of 4 factors. So it can't be a prime number. So what's the point? The point is, composite number or prime numbers are always greater than 1. They are always greater than 1. The condition for prime numbers is that they should have only 2 factors, only and only 2 factors, and no other factors. First factor would be the number 1. The next factor would be that number itself. And apart from 1 and apart from prime numbers, all other numbers are composite numbers. Composite numbers have more than 2 factors. They have more than 2 factors, right? We saw composite numbers with the help of 3 examples. So we know the terms factors, multiples, and exact divisors. And another term that I want to discuss is proper divisors. So let me take an example. Let me take a number. Let's take a number 16. Okay, so 16 is a number, and if someone asks you that what are the factors of 16, so we know that to find the factors, we have to write it like this, like 1 times 16, and 16 could be written as 2 times 8, and 16 could be written as 4 times 4. Is there any other possibility? No, there is no other possibility, right? These are the only factors. Like, you can write it like 16 as 8 times 2, but again this one and this one are same. I mean, there's no difference in that. So there, how many factors 16 has? So 16 has 1, 2, 3, 4, 5 factors. That is, the factors are 1, 2, 4, 8, and 16. So we know that the number itself is a factor of the number. I mean, if in this case 16 is a number and we have to find the factor, so that number itself would be the factor of it. These set of numbers, that is 1, 2, 4, and 8, these are the proper divisors of 16. So what we get from it is, exclude that number, that particular number itself, from the factor list. Like in this case, 16 had 5 factors, out of which one factor would be 16 itself. So remove this one, and the remaining factors would be the proper divisors of that particular number. So in this case, what are the proper divisors? So in this case, the proper divisors would be, proper divisors are 1, 2, 4, and 8. These are the proper divisors. Let's take one more example. Let's take number 20. So 20 can be written as 1 times 20. These will be the two factors. I mean, the very first one would be this one, right? What will naturally come into your mind. The next one would be 2 times 10. Now, of course, this can be written as 10 times 2 also. So both are same things, right? Then we can write it as 4 times 5, right? Are there any other possibilities to find the proper divisors? No. These are the only possibilities to find the proper divisor. The factors for 20. So what are the factors of 20? The factors of 20 are 1, 20, 2, 10, 4 and 5. So the factors of 20 are 1, 2, 4, 5, 10 and 20. Now, we saw in the previous example, that is for the number 16, we saw that if we remove that particular number from the factors list, then the remaining factors would be the proper divisors of that number. So similarly, in this case, if we remove 20, that is exclude 20, and the remaining numbers are the proper divisors of that, factors are the proper divisors of that number. So in this case, 1, 2, 4, 5 and 10 would be the proper divisors of number 20. So now let's move to the perfect numbers. So if you are asked that whether any given number is perfect or not, then what would be the way to do it? So the perfect numbers are those numbers whose sum of all the proper divisors is equal to that number itself. What does that mean? Let's take number 5. So 5 can be written as, in the form of factors, can be written as 1 times 5, right? And are there any other factors possible? The answer is no. 5 is a prime number, and any prime number has only two factors, that is 1 and another factor would be that number itself. So in this case, first factor is 1 and the next factor is 5. 5 is a prime number. So going by this definition, which we saw here, that whose sum of all the proper divisors is equal to that number itself. In this case, like we saw in the previous video, that the proper divisors of any number is all the factors other than that number itself. So in this case, 1 is the only proper divisor. So there is no point of adding anything in that, because it says the sum of all the proper divisors is equal to that number itself. So that the proper divisor is only 1 and the number is 5. So 1 is not equal to 5, therefore 5 is not a perfect number. What about 3? 3 is also a prime number, you know that, and it could be written as in the form of factors 1 times 3, and the proper divisor of 3 is 1. So you cannot add any other thing into 1, because there's only one proper divisor. There's only one proper divisor for 3, and that is 1. And of course 1 is not equal to 3 in any case, because 3 is a prime number and it has only one proper divisor, that is 1, and of course 1 is not equal to 3. So 3 is also not a perfect number. Neither 5 nor 3, both are not a perfect number. What about 6? What about 6? So you would say, hey, I can write 6 in the form of factors as 1 times 6, and I can write it as 2 times 3 also. So you would say that, hey, there are 4 factors for 6, that is 1, 6, 2 and 3, but there are 3 proper divisors. Going by the definition of proper divisors, we know that we have only 3 proper divisors, that is 1, 2 and 3. So you write down all the proper divisors here, 1 and then 2 and then 3. Now going by this definition, it says that perfect numbers are those numbers whose sum of all the proper divisors is equal to that number itself. So in this case we have 3 proper divisors, and if we add it, the proper divisors, if we add it, we get the number 6. And hey, this number 6 and this number 6 is equal. So the sum of proper divisors is equal to that number itself. Therefore 6 is a perfect number. Therefore 6 is a perfect number. What about 7? What about 7? So you would again say that hey, 7 is a prime number. We know that, and it could be written as 1 times 7. Of course, there's only one proper divisor, that is 1. And of course, you cannot find the sum of all the proper divisors because it has only one proper divisor, and 1 is of course not equal to 7. Therefore 7 is not a perfect number. What about 9? So 9 could be written as 1 times 9 in the form of factors, 1 times 9 and 3 times 3. So there are 4 factors of 9, that is 1, 9, 3. There are 3 factors for 9, that is 1, 9 and 3, and therefore you have 2 proper divisors of 9, and that are 1 and 3. And going by this definition, if you add these 2 numbers, you get only 4, and 4 is not equal to 9. Therefore this is not a perfect number. 9 is not a perfect number. Now you would be wondering that hey, then what's the next perfect number? Like if you found for 6, and what's the next perfect number? So I want to tell you that for after 6 you have the number 28 as a perfect number. You would be surprised that hey, the first number that was perfect is 6, and the next one is 28. Between 6 and 28 there are no other perfect numbers that satisfy that condition. So for 28 you can check it. Let's move to some other page. New layer. Let's take for 28. So you can write 28 as 1 times 28, and you can write it as 2 times 14, and you can write it as 4 times 7. Now there are 6 total number of 6 total number factors. There are total 6 factors for 28, and those are 1, 28, 2, 14, 4 and 7. Therefore the proper divisors for 28 are 1, then 2, then 14, then let me take first 4, and then 7, then 7, and then 14. These are all proper divisors of 28, and if you add these numbers, then this number would be 2 plus 1 is 3, 3 plus 4 is 7, 7 plus 7 is 14, and 14 plus 14 is 28. That is, if you add all these numbers, you will get 28. And hey, we have 28 here and we have 28 here. That is, 28 was in the question, and 28 is the sum of all the proper divisors. So it satisfies our definition of a perfect number. That is, the sum of all the proper divisors should be equal to that number itself. Then that number would be a perfect number.